Right, this video is going to show you how to integrate more complicated functions. We've already looked at using substitution when we have a function times a function, because there's no real rules for us at the moment of how to integrate a function times a function or a function divided by a function. So we have a look at these 5 expressions in front of us. We're going to try and integrate those. You can see from the first one here that if you try to use substitution, it would not work, because no matter what you let u equal, it's not going to happen. Okay, so this rule here, can you please make sure that you write that down on your formula sheet? And we're going to have a look, or your piece of paper, I'm going to have a look at looking at integrating the first function using this process. Right, so the first thing we need to do is we need to assign which of our 2 functions that we have here. We've got 2 functions being x and of course e to the x. We want one of them to be a function here, u, and we will have to differentiate u. So you want to try and find or choose the function that differentiates to be quite nicely or easily, and preferably it has a constant as its derivative, because it's going to end up being that we have to integrate that again. So clearly for us, if we let u be x, its derivative is then 1. And that makes the derivative function, right, so v dashed, that's going to be e to the x. So we need to find its integral because v is going to be in it. So the integral of e to the x is in fact another easy one, e to the x. Okay, so now we apply this formula / rule, and I like to write my u's and u dashes and all that sort of stuff like this, because if we look at our formula here, uv, it's that diagonal, we times them together, and then we integrate the derivative of u times v, so then it's those 2. And if I am consistent with that, it's just the same thing over and over again, I don't really have to remember my rule. So here we go, u times v comes x times e to the x minus the integral of the derivative of u times v, so it's just this one here, so that's going to be 1 times e to the x, and now that is something that's quite nice to integrate, so we keep that first, and the integral of e to the x is in fact e to the x, and don't forget you still have to put your plus c, and that's it. Now you can check, you can integrate this to see that you get the original function. I'll leave that to you. Now let's have a look at number 2. Okay, so we've got this one. I was actually going to do one before this, which was going to be try and find the integral of x ln x. You might try that by yourself, because of the first question we did, a lot of you would go, oh, well, let's just choose that to be our u function. Now we can't do that, because if we let x be our u function, that would mean this is our derivative function, and can we integrate ln x? Hopefully the answer to that you're going to say is no. So that's a bit of an example of where it's not always going to be, oh, let's just first function be u. So in this case, because we could not, or we cannot differentiate ln x, that means it has to be our u function, because we can differentiate that. So that becomes u dashed is 1 on x. Okay, and that makes our derivative function 2 x cubed. So now when we integrate that, okay, we're going to add 1, divide by the 4, and so the 2 and the 4 cancel and we get the half. Once again, we pop it into our formula, which means we're going to do those 2 times together first. So that's going to be x to the 4 on 2 times ln x, and I write it like that so I'm not confused. If I wrote it like ln x times x to the 4 over 2, then I probably have to have brackets around that, so that's fine to write if you so desire. Okay, minus the integral. Now we're going to times these 2 together, so that becomes 1 on x times x to the 4 on 2, before I go straight into integrating that. I'm going to simplify first. So that cancels to be, it's not equals, that cancels to be, cancel that. And away we go, and we can just integrate that first one, and then we're going to increase our power by 1. Now divide by, that's going to be 2 times 4, so over 8, and again, there's our plus c. Okay. Now let's have a look at number 3. Okay, a little bit of trig now involved. So first thing we have to do, what one are we going to assign to be our u, and which one is going to be our one we have to integrate. So if I let v dashed be x squared, when I integrate that, it's going to become an x cubed, and that's just going to make it a lot worse. So I'm going to make the choice, and remember, you can always change it. So if it doesn't work, try something else. So we're going to go x squared for u, and that means u dashed is 2x. Okay, and that means we'll let v dashed be sine x, and the integral of sine x, let's be careful here, it's minus cos x. So again, we pop into our integration by parts, so it's u times v, so that's going to be x squared times negative cos x, so pop the minus out the front there, minus the integral of these two times together, so that will be 2x times minus cos, so that will become plus cos x. Now we've got a bit of an issue here because I can't now integrate what's in here by any rule. So guess what? We're going to use integration by parts for a second time. So we write this out, and you can see now if I let u be 2x, when I differentiate that, I'm going to get a constant. So I should be able to do that. So how about you pause the video and you try and see how that works. Okay, so you're going to let u be 2x. You could actually pull the 2 out the front if you wanted to. Anyway, and v dash is going to be cos x. So you see if you can finish that. So pause it and you have a go. Okay, so hopefully you got the same answer I did from using this. Okay, we times those together. That gave us that. We times these together, gave us that. And of course, when we integrate that expression there, the integral of sine x is the minus. So a minus and a minus becomes a plus. All right, let's go on to number 4. Okay, so have a look at that one. Have a think. What are we going to let our u's and our v's be? So we'll stick with u equals e to the 2x, and v equals our cos x. So go ahead and finish that off to get the first line. Okay, so hopefully you got the same answer as I did there. Okay, so don't forget, you've just multiplied those together, you've multiplied those together, and we've got that happening. So you can see again, what we have here is not something that we are able to integrate unless we use either substitution or parts. And again, substitution won't work, so it's back to parts we go. So we repeat the process and we go, okay, now you could, if you wanted to, pull the 2 out the front. I'm not going to, I'm just going to keep it going because I don't want to write another line. So we will let u equal 2e to the 2x, and v dash will become, yep, you guessed it, sine x. All right, so have a go, do your u dash and your v and write your next line. Now do be careful with the negative here when you apply your rule. All right, so have a go and we'll compare in a moment. Okay, so let's have a score check here. Did you get what I've got? Please be sure to notice the signs. Okay, so when we're popping it in here, this was a minus cos x, so I popped the minus out the front. I kept it here, but remember you've got a minus and a minus, which make a plus, but then you've got the minus out the front, so that's why we've got a minus here. Okay, so go back, double check, hopefully you have what I have there. And you're sort of thinking, well, now what? Because we're back to the same situation where we had up here, and we keep repeating the process. We're just in this infinite loop. Now, here's the little catch, and you might not have seen this, or might have not thought to do this. So this is where you go, yep, let's just have a look. So if I was to write the first expression that we had here, and we put it all on one line, okay, so it's going to be e to the 2x and so on. So I'll just write that. So you can, okay, so I'm just writing it all out, but it's on the same line now. And when I come to this expression here, I'm just going to pop this 4 out the front. So that becomes 4 integral e to the 2x cos x. Now, do you notice anything about this term and this one? So they are in fact the same. So I can just gather my like terms. So I'm going to get rid of this minus 4 lots of that, pop it on the other side, and it's going to become plus 4 lots of. So if I've got one of these plus 4 lots of these, absolutely, we end up with 5 lots of e to the 2x cos x. Write everything again. And remember, what is it that we wanted? We wanted to find the integral of just e to the 2x cos x. So that's it here. So to get rid of that times 5, we're going to divide by 5 or times by 1/5. So we can now say, therefore, the integral of e to the 2x cos x is 1/5 times all of this. And we'll just, because I don't want to have to keep writing everything, we can also see e to the 2x is a common factor. So that is sin x plus 2 cos x, and somewhere around there, yes, I forgot to put the plus c, so make sure that you add that. Okay, so a little bit of a trick there. If you find that you're going into this infinite loop, go back and look at your original and see if you can pop some common factors on one side. All right, we've got one more to go. Let's go and have a look at number 5. So slightly different, so no trig this time, but we've got an ln. And hopefully you recall that we cannot integrate ln x, so therefore you're going to need to say, well, u is going to have to be ln of 3x, and that means v dashed will be x plus 1 all squared. So stop the video, see what you're going to do for the next steps, see how far you get. How'd we go there? So differentiated your ln 3x correctly. So we got u dashed equals 1 on x. We integrated our v over here. We do the cross uv and then u dashed v to get this expression. And we think, okay, groovy, except we've got an issue now with trying to integrate this. Do we do by parts again? That's going to get even uglier. So remember, every time that we do an expression, we should be asking ourselves, can we simplify it first? So in this case, I'm actually going to try and simplify it. I'm going to expand my top brackets here. And yep, I'm going to use Pascal to help me. And then simplify with the 1 on x out the front there. So let's see, you do it. Okay, so using Pascal, we expanded that top, x cubed plus 3x squared plus 3x plus 1. The 3 times x, I just pulled out 1/3 at the front here just to alleviate that. And now all I have to do is divide through by my x. So we'll write this again, becomes x plus 1 cubed all over 3 by ln x minus 1/3. We're still integrating, but now I'm dividing by x. So x cubed divided by x is x squared plus 3x plus, now 3x divided by x, that's just 3. And we get 1 over x there. Now it's up to you. You can put everything over 3 if you want, or you can do it bit by bit. But we can now integrate term by term. Okay, so you finish that off as I will. Okay, and that's now going to be 3x squared over 2 plus 3x plus ln x. There's our plus c, and now we can times everything through by the negative 1/3. Okay, and there we have it. So hopefully that gives you a bit of confidence using integration by parts. So now go and have a look at the questions in your textbook and see how you go. Let me know if you've got any problems.